Hello students, today we will study the exercise number 6.4. This is the topic of standard 10, chapter number 6, triangles. So question number 1, what is this? Question number 1 is, let triangle ABC and triangle DEF similar. That we have given the condition that triangle ABC is similar to triangle DEF and their areas be respectively 64 centimeter square and 121 centimeter square. If EF is equals to 15.4 centimeter, find BC. So here we have given that the two areas of these two triangles, and we have said that the two triangles are similar. Now remember, according to the theorem 6.6, that the area of the two similar triangles, if we take the ratio, then it will be equal to the square of the corresponding ratio of the corresponding sides. That is, we can write down here is that area of ABC upon area of BEF, that is the ratio of the two similar triangle, that is equals to, if we are taking here one of the side that we have given is BC. If we are taking the BC side of triangle ABC, then we have to take the side EF, and ratio of these two sides, and this is the square of this ratio of the square of this ratio, right? So this is how we can write down according to the theorem number 6.6. Now here we have given the value, that is of area of triangle ABC, and that is 64 centimeter square. In the same way, the area of DEF we have given is that 121 centimeter square. 121 centimeter square. Now one more thing we have given is that, okay, we have to find out the BC, and we have given the value of EF, that is 15.4, and this is the square. Now if we take the square root both the side, what we will get here, the square root of 64 is 8, the square root of 121 is 11. Here we get the square root, that is BC, and here we get 15.4, right? Now to find out the value of BC, when we make the BC as a subject, we have to multiply this 15.4 with the 8, that is 8 multiplied by 15.4, and we have to divide it with the 11, right? So now let us cut this 11 with this 15.4, that is 11 ones are 11, right? 4 is the remainder. Decimal point is there, so we have to put decimal here. Now 44 is there, so 11 fours are 44. So here we are getting 1.4, and 1.4 eights are, that is 14 eights are. So we can write down BC is equals to 8 fours are 32, 2 is the 3 is the carry, 8 ones are 8, 9, 10 and 11. That is 11.2, and this is the unit is in centimeter. So this is the required side BC, right? So simply we have to use here the theorem number 6.6 to find out our result. Okay. Now question number 2. Question number 2 is, diagonals of a trapezium ABCD with AB parallel to DC intersect each other at point O. If AB is equals to 2CD, find the ratio of the areas of triangle AOB and COD, right? So here there is a trapezium ABCD in which diagonal AC and BD intersect each other at point O. We have to find out the ratio of the area of triangle AOB to COD, right? Okay. So now consider both this triangle. Can we prove that these two triangles are similar? Yes, we can prove that the two triangles are similar. So let us consider triangle AOB and triangle COD, right? In with both this triangle, see, one of the angles this and this. These two angles are vertically opposite angles. So we can write down one of the conditions, that is angle AOB is equals to angle COD. This we can write down according to the vertically opposite angle. Second condition, here we know that this is a trapezium. So AB line is parallel to DC line. So this angle and this angle will also become equal according to the alternate interior angle. So we can write down angle ABO will become equal to angle CDO. This we can write down according to the alternate interior angle. Now only two conditions are required to prove the two triangles similar. So here we can write down that triangle AOB is similar to triangle COD according to the angle rule or angle criteria. Now if the two triangles are similar, we know that their areas, the ratio of their areas, that is we can write down here area of AOB upon area of COD. This ratio we can write down as the ratio of their square of the ratio of their corresponding sides. That is, if we are taking the side AB, then here we have to take side CD, but we have to make the square here. Right? Now we know that we have given here is that AB is equals to 2 CD. Right? So when we take this CD to the denominator of the AB, then what will we get? C. Here we are getting AB upon CD is equals to 2. Right? So here this value of AB upon CD, what we get? 2. So here put down 2. Or we can simply say that 2 upon 1 square. That is 2 square is 4 and 1 square is 1. That is the area of triangle AOB upon area of triangle COD. That we can write down, this is equals to 4:1. Right? So this is how we can solve this question number 2. Okay? Okay, so let us continue with the question number 3. Question number 3 is, here we have given one of the figure, that is ABC and DBC are two triangles on the same base BC. Okay, and if AD intersect BC at O, so that area of ABC, that we have to prove here is that area of ABC over area of DBC is equals to AO upon DO. Right? So where is triangle ABC? Triangle ABC is this. Triangle DBC is this. Both are on the same base BC. Right? So see here we have not given that ABDC quadrilateral is a trapezium. It is not given here. So we cannot use any of the criteria, that is of parallel sides. Right? So here we have to prove that area of ABC upon area of DBC. So anyhow here also we cannot prove that these two triangles are similar. So to find out the area of the triangle ABC, that is we know the method, that is 1/2 base into altitude. According to that, let us draw one of the perpendicular from here, that is M, and one of the perpendicular from this D point on this side, and give it the name N. So what we are doing here is, let draw AN, that is perpendicular to BC. In the same way, one another perpendicular we have drawn, that is DN. It is also perpendicular to BC. Why we are drawing the perpendiculars? Because we want to find out the area of triangle ABC. Now, if we take the ratio of this area of triangle ABC to DBC, what we can write down? C. Area of ABC over area of DBC. Okay, according to the formula, we have to write down area of triangle ABC as 1/2 into base. Base is BC. And what is the altitude that we have drawn here? that is A. In the same way, here also area of triangle DBC we can write down as 1/2. Here also the base will remain the same, BC, and altitude will become DN. Now see, 1/2 BC will cancel out each other. What will remain? Area of ABC upon area of DBC is equals to AM upon DN. Okay, give it the equation number 1. See, here we have to prove that the area, this ratio is equals to AO upon DO. Here we get the ratio, that is AM upon DN. So, if anyhow we can equate these two ratios, A upon DE is equals to AM upon DN, then we can, by comparing these two, we can get the required result. But how we can compare it? We know that if the two triangles are similar, then corresponding sides are in the same proportion. So consider the two triangles which consider AO side and AM side. So AO side and AM side. This triangle here we can take that AMO. So consider triangle AMO. And second triangle that consider DO side and DN side. So DO side is here and DN side is here. So we can consider this another triangle, that is DNO. Triangle DNO. Right? Now what we have to do, that you know very well, we have to prove that the two triangles are similar. So see, as we have drawn here the perpendiculars, we know that the triangle AMO will become angle AMO and angle DNO. Both will become equal because both are of 90 degree, right? Can you think about the second condition? Yes, obviously. See, these are the vertically opposite angles. So these angles we can write down as angle AMO. Angle AMO. And this angle we can write down as AMO, not AMO. It is AOM. AOM. And second angle we can write down as a DOC. These two angles are similar because, DON. These are the vertically opposite angles. Now, if the two angles are equal, then we can write down that triangle AMO is similar to triangle DNO. By which criteria? Angle rule or angle criteria. Now we know that as the two triangles are similar, their corresponding sides are in the same proportion. So we can write down that AM upon DN is equals to AO upon DO. AO upon DO. See, third condition we do not need to write down. Actually we can write down, but here we required AO upon DO, that we get here. Here we have proved that AM upon DN, that we get here. We with the equation number 2. Now see, when we compare both these equations, compare equation number 1 and 2. When we compare both these equations, the right hand side here is AM upon DN, left hand side is here AM upon DN. So this equals to this and this equals to this. That means we can write down that area of ABC upon area of DBC, that will become equal to AM upon DN. And that is what the required, here we have to write down AO upon BO. And this is the required result, right? So this is how we can solve this type of question using theorem number 6.6 and using the similarity of criteria of the similarity. So this is all about this lecture. Thank you.